What's up guys? How you all doing? Hey, welcome back to the channel. I'm going to be checking out today the Sunkko 709A battery cell welder. If that sounds like something you'd be interested in, please stay tuned because it's coming up right here, right now on misperry. Okay guys, so like the intro said, we're going to be reviewing a battery welder. Now, the cool thing about this is if you don't know anything about battery welding, I'm going to try to go through it, give you a little bit of concept behind it. So essentially a battery, lots of times these batteries, like this 18650, they're flat. They come flat, they don't have any type of a projection on them, so they're very difficult to snap into a battery holder. Now they do make battery holders for it. In fact, I have some that I've used in other projects and whatnot, but the fact of the matter is the best and most reliable way that you can get these to work is you have to weld a tab to these. Now, there's been multiple people make up kind of their own welders and things like that. The idea behind welding these batteries is if you stuck a normal welder on this, you would probably explode the battery. So it presents a problem. How do you weld a tab to these batteries without actually damaging the battery? So that is where this battery welder comes from, and I want to take this moment to thank our friends at Sunkko. They were the ones that sent this to me to review. They make a wide variety of them. This is just one model. Like I said, this is the 709A from Sunkko. They were gracious enough to send this to me so I could review it for you guys here. This model is the model that goes, I think it's about 1.5 kW. It can deliver up to 500 amps of DC to actually weld the tabs onto the batteries. It also comes with a handpiece, so if you have larger packs, the welding terminals are up here, and we'll have a close-up shot here in a minute, but it comes with a handpiece, so that way if you have a bigger battery, you can do it out here where you've got more space. It also comes with, this particular model, comes with a soldering iron, so we'll be reviewing that and checking out that soldering iron, see how well it works and whatnot. It also comes with a 4, 6, and 8 pulse mode, so it basically pulses. So real quick, let's go ahead and let's get into the theory of this thing. All right, so the theory behind a battery welder is that they are what's called a resistance welder. A resistance welder, how they work is it's based on resistance, right? The high resistance that is between, let's say, a tab, a nickel tab, and the battery will actually cause the nickel to melt into the battery when you pass enough current through it. So you get some nickel tabs. They're literally strips of nickel metal. And I highly recommend the pure nickel. I've been using some of that. They give you a lot of different types of metal. They give you nickel plated iron, pure nickel, and that looks like about what it is. And they're all different. I think they're different thicknesses. 12.2 milliohms per 100 millimeter, 31.3 milliohms per 100 meter. They give you a bunch of different ones so you can experiment with your batteries, right? So that all matters when you're doing resistive welding. Now, me personally, I have done resistive welding before with a much bigger and much more industrial size battery welder. So I'm sure there's going to be some differences, but I do have some experience with it. The idea behind this is you have 2 electrodes. I'll see if maybe I can find a picture and flash it up. If I can, then great. If I can't, I'll try to explain it to you best I can. You have 2 electrodes, and that's what's on this machine and on the handpiece. And the 2 electrodes come down, you place the tab on top of the battery, and I'll demonstrate all this. We'll be demoing it and playing around with this, so we'll see that here later on in the video, so make sure you don't go away. Anyway, you place a tab on this, and what it does is it's actually easier. The 2 electrodes are a positive and negative terminal, okay? And it's easier for the current when the touches down on here. You want to make a path where it's easier, instead of just shorting across to the 2 terminals, it's easier to actually, for the electricity to actually penetrate down into the surface of the can in these batteries, go over and then back up into the other terminal, and where those are touching, it basically fuses it together because it's a high resistance path that it's going through. And so when you push that much current through there, it actually melts the nickel. And usually these are either nickel plated or they're aluminum, or sometimes they're steel that's on these cans. and it melts the two metals together and creates a good fusion. So that's what we're going to be checking out. So I'm going to probably switch to my other camera here real quick, and we will go on to the bench and we will check out at a closer look, and we'll see how we weld up some batteries. We'll be doing some test welds, and that's another cool thing that Sunkko, these guys provide you, is they provide you a test weld strip. So this looks like, I don't know, to me it looks like probably a piece of really thin gauge steel, is what I'm going to guess, with a nickel tab on it. So we will be playing around with this since they gave it to us to play with. We're gonna play with this too, just to see how the welding works. And I've also got some other gauge steel that I have in my garage. We'll be cutting that up. We'll be checking it out, and we'll see how well it does, and then we'll end up trying to weld up a battery pack. So stay tuned. I'm going to slip this around, and we'll check out the Sunkko 709A battery welder. Okay guys, so I got us all set up here at the bench of this thing. So it comes with two copper electrodes. These are the two little guys that are going to push down on it. Now up here up top, let's see if you can see that. Hold on, let me back up a little bit. Ooh, too much. Up here's a little dial. That's basically the pressure that this will push down with. Basically it's like a spring tensioner. It adds more tension because pressure is yet another variable that you can do. You've got the current, you've got pulses, you've got pressure, you've got a bunch of different variables that you have to play with to get the right weld. Now, let me show you what they have done. I've actually kind of practiced with it a little bit. I don't know if you can see it. I don't have a light, but you want to see the weld actually go all the way through. I don't know if you can see the little dots on that. See if I can zoom in far enough. See if we can zoom in. See the little dots on that? You want the weld, when you weld a tab down, you want to see the dots on this side, and you want to see the dots come through on the metal. That lets you know that it penetrated all the way through the metal. Okay, so let's back up here. All right, so we definitely want to see that. Now this is a pretty thin gauge steel. I've cut a piece of really thick gauge steel that I had in the garage. We'll try welding to this and see how well it does. The idea is you want the weld to be strong enough to where it kind of takes chunks when you rip it off. It takes chunks out of the other piece of metal. So if I were to pull this off of here, if I can, which is a good sign if I can't. All right, so I just ripped the tab off of this, and I can feel it, and yeah, there are chunks missing when I'm looking at it. So let's see, let me undo this and I'll show you. Let's zoom in. Okay, let's zoom in. I don't know if you can see it, but there's little dents right here that are taken out of the metal. Let's show the other piece right here. I can actually feel it. That's actually rough, is what that is. And so that's because of it. Oh, my wife's here with me. Hi. Hi, honey.
Hi.
How are you? You're tired?
No, I was just, okay, good.
I'm tired too. Anyway, so my wife's gracing me with her presence. All right, let's back up. So let's go ahead and see if we can't weld another one of these tabs back on. Now I have no idea what tab that was. Like I said, they give you kind of a test strip. So what we're going to do is I'm going to try some of these. This one is a nickel plated iron. It's about 12.2 milliohms per 100 millimeters. So we're going to give that a shot. Now I do want to try a couple of different things. From the past when I used to do this, there's a few different ways that you can, and little tips and tricks that you can do. We're going to try welding the tab just by itself. What are you trying to get in the camera?
I was just seeing what you have going on there.
All right, so we're going to try to weld just this strip down just plain the way it is. Now, what I've usually seen is the strip will be split down the center to improve the basically, if you cut a split down the middle, it's going to cause the electricity to have to travel further, so it will penetrate deeper into the can of the battery usually. So what I'm going to do is I'm going to put this on here. Now you don't want to touch this with your hands, because otherwise, you don't want to take a chance on 500 amps going through your hands. So first thing that I see is actually pretty cool. I don't know if you saw that, but it has little LEDs on the underside of this thing. Here, let me turn down one of my lights and I can show you. So if you can see that, there's a little LED light underneath there. So that's kind of a cool touch. That way you can you really see where the electrodes are touching. So let's see if I can zoom in any further. Zoom in pretty hard. There we go. All right, so what I'm going to do is I'm leaving the pressure and everything the same. I'm going to turn the weld up to halfway, and I'm going to do no just a single pulse. Now, I do have the foot pedal connected. There's a foot pedal feature. So what I'm going to do is I'm going to push this up to where it's got some pressure on it, and then I'm going to step down. Ooh, I even saw a spark. Okay, that really didn't take. It didn't take very well. So let's go ahead and let's try that again. I'm going to increase the weld power to 6. Let's see what happens now with the weld power at 6. So get on it. Hopefully you guys can see this. And we're going to hit it. All right, so it zapped. Yep, still not a good weld. So what I'm going to do is now I'm going to increase and do a couple of pulses. What this will do is it will basically hit 4 times. I've got it on 4P, which is 4 pulses. So we're going to let it hit 4 times is when I press down the button. All right, so let's go ahead and let's get her back up there. Get it on there. And here we go. All right, so there it was. Oh, that did a little better. That did a little better. That's still at 6 so far as the welding goes. Here, let me back up so you can see it. So up here, I've got this dial set to 6, this red dial, or at least, you know, roughly whereabouts. All right, so let's see if I can pull it off with my fingers. Ah, okay, I can pull it off with my fingers. So that's not very good. So what we're going to do is we will try 6 pulses. Let's try that now. Oh, and it looks like you can... Okay, it looks like you can stack up the pulses. All right. Oh, and by the way, this review of this thing, I have not yet used this at all, so this is all uncharted territory for me. So let's try 6 pulses. Let's go on up. Okay, so I'm going to put it up, and we're going to give it a hit. All right, I saw some smoke on that one. Woo! Saw some dents. Yeah, I think I'm seeing some little dots on the underside. That's pretty good. Yeah, it was fairly easily removed, though. And so the idea behind getting a good weld is you want to get it where it isn't, because if you have any type of vibration, you don't want it to break loose. So I'm going to continue fooling with this. I'll be back in just a second when I find the settings that are going to work for this. All right, so I have hit it with basically all the pulse buttons set. I've set all the pulses, and it looked like it did pretty good. I'm going to flip it over now. We're going to give it a shot on the back side. And it did pretty good. I even saw the little guys come through. So let's put this on here. We'll give her a close shot here so you can see the magic. All right, we're going to go ahead and contact. All right. So that looks pretty good, if you can see that. Even some black marks. And on the bottom, I see some black marks on the bottom. So that's pretty good. And it's on there. I can't pull it off. Get a pair of pliers here. See what we can do. Okay, now looking at it, if I flatten it out, if you guys can see that, but you can see where the welds were. So all right, so that looks to be pretty good for this thick a sheet metal. I'll probably write that down. That thick a sheet metal, or at least thick of a can, and these tabs, which this was the, let's look at it, this was the 12.2 milliohm per 100 millimeter tab, does pretty good. This is a nickel plated iron, so that's actually pretty good on that. Huh, let's up it a little ways. Let's try the thick one, shall we? Get the thick one going. Here, let's get a new strip. Let's get a new strip here. We'll play with the thick one. All right, so let's see if we can't weld to some thick stuff. See if the same deal happens. All right, ready? Contact. All right, still sounded pretty good. I don't see anything through the bottom. Of course, this is fairly dirty. See if I can peel it off. No, sure put it down flat, didn't it? Come on, baby. There we go. See if I can pull it off with my fingers. Ooh, I can't pull it off with my fingers. Ooh, that's flat on there. That did pretty well. Even on that thick metal, that did pretty well. Well, I wonder, you know what? I'm curious. I'm going to crank up the power and see if I can't get it to penetrate all the way through, shall we? So I'm going to crank up to 7 now. Let's see what happens at 7. And we'll see if we can't put this on here. All right, contact. Ooh, I got some sparkage on that one. See, that looks pretty good. See it go through very well. All right, let's see what happened. See if we can peel this off. All right. Ooh, I think it actually I think it actually poked a hole clear through this tab. Yeah, there's a hole straight through it. See that? There's a hole straight through it. That's very good. And then look at this. You can see chunks missing from the steel. That is an excellent bond. That's excellent. That works really well. All right, now, because I want to try something else. I want to try cutting a groove out of one of these and see if it welds even better. I'm going to leave it at 7, but I'm going to get a pair of cutters here and I'm going to cut a groove out. Okay, so basically what I did was I took a pair of scissors and I cut a groove out. What I'm trying to do is I want to straddle the electrodes on either side of it and see if it will still weld. So let's give that a shot. So here we go. Let me get my, oops, sorry, I didn't mean to kick the camera. Let me get my foot on the pedal. And let's see what we can do if we put it on either side of that groove, see what happens. And contact. Ooh, I saw sparks. Well, that looked pretty good. Still nothing on the bottom, but that doesn't necessarily mean anything. And so let's see if we can peel it off here. Ooh, it feels pretty good. Ugh. Oh yeah, look at that. I don't know if you guys can see that. It's literally got chunks of metal stuck to it. Like, let's see if I can zoom in any further. Can you see that? It's kind of hard to see. It won't focus very well. See that? Those are actually chunks of metal. That's an awesome weld. Excellent. All right, so now what we're going to do is we're going to, let's back up. Let's give the handpiece a shot. We're going to back way out, and we'll take our small piece of metal, and we'll do a handpiece. Also, another trick with these, at least from using the industrial units, sometimes they carbon up from all that. Get yourself a sheet of, oh, I don't know, fairly loose grit. I think this is 220 or something, and just kind of give them a little bit of a scratch. Just a little bit, and that'll knock any carbon off of these electrodes. All right, so let's give the handpiece a try. All right, so this is the handpiece. I've got this on here. Same deal. I'm going to use the pedal to activate it. Use the same settings and everything. Let me get a new strip of metal here. Well, this one might work. Well, let's get a new strip. I'm going to dangle this off here. Let's get a new strip of metal. We'll keep with this nickel-plated iron since we've been doing quite well with it. Okay, here we go. So I'm going to go ahead and take our handpiece here. You can loosen the screws. There's screws in the ends of this. You can loosen these and spread the electrodes out further if you want to, or push them closer together. It's up to you. They're also spring-loaded, so that way you've got some tension, kind of like the pressure on the units, or on the ones that's on the base unit. So let's go ahead and let's put this on here. So I'm going to press down with some pretty good force, and it looks like they spread out when you press it down. Let me get this turned where you might be able to see it a little better. I'm kind of creating a shadow, aren't I? That's okay. So I'm going to push down. Whoa, that's a little too much force. Well, let's try that again. All right, contact. All right, I saw some smoke, so that's probably a good thing. Well, we did scorch the table. Okay, well, let's not scorch the table again. All right, contact. All right, we did it. And not a whole lot. It didn't really even, take. Okay, well, let's turn it up to maximum strength, shall we? I've got it up on 8. Let's give that a shot. Push down, hit. Oh yes. Okay, that one looks like that might have been a success. Ooh, it's nice and hot too. That's another thing you got to be careful with. These things get hot. All right, let's rip this off and see. Oh no, it came right off. Came right off. Well, I don't know about the handpiece. Let's try a pure nickel tab next. Okay, so now I've got a pure nickel tab. These are a lot thicker, and it feels like it's a lot thinner. The tab is a whole lot thinner. So let's see if we cut a piece of this. Cut a piece of that. Let's see what that does if we put that on here. I'm going to turn the power down because I don't think we need to be on maximum power, but I'm still going to leave the 4, 6, and 8 pulse buttons selected. So let's see what, and this is at about 5.5 power. Contact. Okay, I didn't see a whole lot happen. Nah, That's wimpy. Let's crank it up to 7. Crank it up to 7. Contact. Okay. Nope, hardly anything. Let's crank it up to 8, and I'm going to leave it on just 8 pulses. Okay, 8P is what I'm going to do. And go. It's not fusing the metal together. That's very interesting. All right, so the handpiece, I don't know. I may have to play with this more. I'm not going to do it here because I'll be here all day. But the handpiece looks like, I don't know. Could be better. I could be using it wrong. Only time will tell. May have to RTFM. They do send you good instructions, so we'll check that out. Now, the next thing we need to check out, though, is does the soldering iron, how does that work? So let's reset up for soldering and see how the soldering iron works. Okay, so I've got us all set up for the iron. So now, this soldering iron, it's very interesting. It's kind of, the whole tip comes out, so I guess that's how you change it. So it's kind of almost, in a way, like a met cowl in a way. We'll see how well it works. I'm going to go ahead and turn it on. We've got our power up here, so I'm going to flip that on. That's that other button, and we're going to give it, we'll give it some oomph. I don't know, do I have to turn the welder on too? Oh, you have to turn both of them on. Oh, all right. All right, let's set it for, oh, I don't know, let's set it for 300 maybe. Ooh, comes the heat pretty quick. All right. Feels hot. All right, so let's get some solder. This solder that I'm going to be using is just regular 6337, so it's 63% lead, 37% tin, or whatever that is, or maybe the other way around, I don't remember. But anyway, let's see what it does. Now, first thing we need to do, we need to get some water on our pad here. Let's see. Woo, there it goes. It's kind of interesting they sent me a square pad and a round disc, but that's okay, as long as it's got some water on it. How hot are we? This makes me wonder if this is Fahrenheit or Celsius I'm looking at here. Now we'll go on up to 400. I don't know, I'm listening to it. Not hearing. Oh well. Okay, so always have one of these. These are always very handy. All right, so it feels pretty hot. See how we do on melt and solder. I even got some wire set up, like I'm going to solder some wire, and we'll see what it does. Let's go ahead. Ooh, yeah, that's doing pretty good. We'll tin the tip here. All right, so let's wipe that off. Get that all nice and tinned up. I don't know, it looks pretty good. I mean, the tip's pretty good. Let's see if I can zoom in here. Zoom in on our wire here. Oh, tip looks pretty good. Let's give it a shot. See how well we do here. Well, it's looking pretty good. Melting the solder just fine. Now, here's a test that I like to do on everything. Does the very tip get hot? Most irons, the answer is no, it doesn't. But this one, you know, believe it or not, it seems like it's gonna work. Look at that. Well, I would say that's a success. It's not getting overly hot in my hand. I do like the pencil grip. The plastic feels kind of chintzy though, but so you know it might break. The plastic handle might break over time, but no, I'm actually fairly pleasantly surprised. I was thinking this was going to be, you know, just kind of real chintzy, but it's not. It's actually pretty good. All right, now the real test is going to be. Let me go get the other solder. We'll solder up some stuff using the ROHS compliant lead-free solder, which takes a higher temperature and is a little bit more difficult to work with. So let's see if we do that. But that is a nice, shiny, yeah, no problems with heat there. Okay, guys, so I went ahead and got me some of the old lead-free solder here. This is 0.04 diameter, so 40 thousandths diameter. It is 99.3 silver and 0.7 copper rosin core. So anyway, this is a pretty big thick chunk, but let's see how well it does on this. Now I'm gonna guess I may have to crank up the power a little more on it, but we'll see. I don't know, it's melting it. Oops, can you see? Yeah, here we go. I don't know, it's melting it quite well. All right, well, we'll tin the tip with this. Now, normally I wouldn't recommend this. I would have separate tips. If you're going to be using the ROHS stuff, I would have separate tips because a lot of times when you contaminate the two metals, it'll actually cause the melting temp to actually go higher if the tin lead kind mixes with the others. So I would probably buy another tip for this. I'm assuming you totally can from Sunkko's website. But anyway, so it's looking pretty good. All right, let's get on here and see what kind of heat we can deal with. And it's a little more difficult, but it is doing it. I'm going to turn the heat up a little bit. I'm going to probably go up to maybe 450. Let's see. See how that does. See how well she does here. Well, looking pretty good. I'm still using the very tip. I'm actually fairly impressed. This is going really well. Look at that. Look at that. I don't know if you guys can see that. Can you see that? Look at that. That's actually darn good. That's actually darn good right there. I'm impressed. That's a good solid connection right there. That's great. Okay, so now that we have checked all of that out, we're going to go ahead and do the real thing. We're going to go ahead and weld up a battery pack. What I'm going to do is these guys are a 18650. They are 6800 milliamp hours, which I don't know if I believe. I got them off of Fleabay, as Ave would say. 3.7 lithium ion. So what we're going to do is we're going to go ahead and we're going to weld this tab to it. So what I'm going to do is I'm going to place this like so. I'm going to push up. Let's see if we can hit her. And contact. There it was. Now, that's actually on there pretty darn good. So let's get the other one. We want to put this guy together. So these are going to be the two batteries. So let's get him positioned real good. Put that up here like so, and contact. There we go. There's two batteries together on that side. That's looking like that's doing pretty good. So let's try the next one. Let's cut a chunk off, and let's go ahead and give the other side a shot. So here we go. Now what I'm going to do, that sounds like everybody and their mother's walking through here while I'm trying to make a video, but that's okay. We will endeavor to persevere. So let's go ahead and hit this one. Now this one's going to be interesting because the can is quite small. So let's go ahead and see if we can give the shot here. And contact. All right. Yeah, they look like looks like it's stuck, so we're good to go there. Let's go on the other side of the can. We'll get it positioned up, get some pressure on it, and contact. There it is. There we are. There is a perfectly good battery pack. So now what we need to do is we need to put on the wires to connect it. So what we need to do is we'll need to use our soldering iron here, and we'll connect it up. So let's go ahead and I'll fire up the soldering iron and get some other stuff to connect that up. Okay, so here we go. We got our soldering iron all hooked up here. So what I'm going to do, there we go. This is the positive side of the can, so I'm going to put a positive on. Here we go. Wow, that looks horrible. Oh, dearie me. It's like I haven't ever soldered before or something. There we go. There we go. That's better. Okay, so that's that side. There we are. There we are. Nice, neat little battery pack. Now, to complete the ensemble, I've got some shrink wrap for it. Okay, so I've got some of this battery pack material. So what we're going to do is we will cover this guy in it, I suppose. All right, so here we go. We'll also put some for the ends, so I'll use this. We'll just cut this open like that. Cut this like that. And what we'll do is we'll cover the ends of this with that, kind of like that. So let's go ahead and trim this down a little bit. We'll cover up the ends as we slide that in there. There we go. So that way the ends are good to go. I'm going to hit it with the heat gun, be right back. All right, so that actually came out looking pretty good. So there is a, oh, let's see, what would that be? 68 times 2, that's 16, 6, 12, 13.6 amp hour, 3.7 volt lithium ion battery, welded with the Sunkko 709A. Okay guys, so according to this little unit, final thoughts, I say it's very good actually for the price of it. Check the link down in the description, you'll see it. For the price that they are, compared to some of the really expensive ones that are out there, I'm actually pretty shocked and amazed. I'm actually pretty well pleased with this little unit. It does, the soldering iron actually works pretty well. Like I said, the plastic is a little bit on the cheap side, but that's, I mean, that's to be expected. At the price of the unit, that's to be expected. And but it does solder fairly well. It's a good tip. I'm curious to get on their website and see if they don't have any different types of tips, because I'd like to find a fine tip and some other things. And what I do like about it is that it is similar to like the style how a Metcal is, with the tip being shorter. The normal soldering irons, the tip's really long and you're far away from your work. So I'm actually pleasantly surprised with this. I actually was not. I was more on the battery welding side of it and didn't really think that was going to be anything to really shake at, but it's actually pretty darn decent. It's really good. So way to go, Sunkko, on that one. The welder itself, I think is great. I enjoy the foot pedal more. I didn't show you, but you can, if you don't have the foot pedal hooked up to it, it has an internal switch. You can feel it click. I don't know how to explain it. You probably can't hear it because it's very light, but it has an internal switch. You can feel it click, and it will weld if you don't have this plugged in. If you have this unplugged, it'll go ahead and hit when you push up on it. I didn't show that, but details. It's just a different way. I like having the foot pedal. I like being able to push up on it, maybe reposition it, move it around, and not have to worry about accidentally triggering it and it welding it in a weird way. So I like the foot pedal. That's just me. But it does work well. So it does weld batteries. As you can see, we welded up a battery pack. I did a horrible job heat shrinking it though. I got wrinkles in it. But it did weld the battery pack up. So at least I know with the 18650 batteries, at least this kind that I bought, it welds quite well. I know that it'll weld to steel because I did weld it to steel. I may try it with aluminum and maybe some other different metals, see how well it will weld against those. I may post on Twitter. So those of you that don't follow me on Twitter, follow me down below. I may post some more about this, talking about it, different things that I may find out with it. The handpiece, little disappointing. I noticed that one of the plugs though on this is really hard to plug into, and it has kind of smashed in the end here, and so I'm wondering if that might be some of the problem. One of the other plugs is a little bit looser, and so I'm wondering if maybe it wasn't making good contact or something, and so it wasn't really getting the full wham of the current. Now I could twist these. If I twisted these up, then it would take some of the leakage out of it, probably some of the leakage inductance out of it. So I may try that to see if I can't get some better results with it. But so far as the handpiece goes, a little disappointed in that. But again, I may not be using it correctly. And again, watch me on Twitter and social media and whatnot. I will post talking about this, as well as we got a Maker Monday coming up. I'll probably play with this a little more and maybe give you some more pointers and tips on Maker Monday about the Sunkko 709A. Okay guys, sorry about the audio, but I literally got finished filming and then I just figured out the handpiece. So what the deal was is I was putting way too much pressure and it was causing it to basically short out across the bottom. So it's very light pressure. You want to push down on it very lightly and then give it a hit. And there it was, and I did it. And now it's flat on there. I have to pull pretty hard to get it off. So light pressure, light pressure. I wanted to say that. So the handpiece does work. Yay! Good job. So anyway, just wanted to share that little tidbit with you. Final thoughts. I think it's a great little box. I think it works exactly the way as advertised. The handpiece may be a little more research on my end, but so far as the unit itself, works great. Soldering iron isn't perfect, but it solders, it does well, it gets hot enough for ROHS, it does everything that it's supposed to, heats up fairly quick, cools off fairly quick too. I didn't tell you that, but it cools off fairly quick. So I say this is good. This is great. I would recommend this to those of you that maybe RC guys or that you're like me, you just need battery powered projects and stuff. I would highly recommend this unit. So thanks to Sunkko for sending me this unit. It's been fantastic. Check the link down in the description. Get one for yourself. See what you can do. I would say they are a great little unit, so I hope that you enjoyed this review. If you have any questions, post them down below in the comments. I really enjoy talking to you all. And guys, with that ought to do it. Make sure and like, subscribe, and share the videos so we can spread awareness of the Sunkko 709A as a great battery welder. We'll see you in the next video.